Hello friends, let us study about path coverage. Now here, the path coverage is entire code is split into the number of distinct paths. A program or a subprogram can start from the beginning, trace the path to its completion. That means a program or a subpath can start from the beginning and take off the paths to its completion. Now let's say, for example, I've drawn one figure and according to the statement, the branch, that entire thing is coded into a flowchart. So let us see how that is coded. Now, the decision box is made for a if and the statement is if the plain line. Now, mine is very simple that if A is not equal to C, then the comparison is made between A is not equal to C or A is not equal to B. So what could be the output and what you have to print, right? So now if A is not equal to B, then there is a loop again to check to determine whether B is equal to C. So there is a flow of this diagram, right? And my condition checks whether the variables is true or false, and accordingly the loop is executed. So how will you trace the path? First and foremost, you will ask me how it has drawn. Now take a simple code. You take a code of addition and do some if add some if and write generate some conditions that if A is not equal to B, then you do some kind of function again, you start write a code of it, right? So then accordingly you draw the loop. If there is a if statement encounter, you draw a decision bar, or if there is a plain statement encounter, draw a state line just indicating the flow from where it has started and in where it will be stopped with the label 1. This is very simple practice. Try this at home. Then execute. How will you trace? So now my paths are traced as follows. Now initially it will begin with A. Have you seen this A? Now if A is equal to B, okay, that's the comparison made. So then A has written, then A is generated. Then we have B, C, E, next path. So from B, C, can you see the B, C, E path is B. The false where I have written is false, that is B. That entire line is B. From B to C, where the false C is written, that entire line, that entire thing is C, and then again the decision made. So again, if it is made true, then E will execute. So we have the entire thing is print C. So that means B, C, E. There is another path used, generated, and then A, D. So if there is another thing that is a false part, again the false part comes. So that is A and D means if this one, the number of traceable paths, number of coverages. So in this way, the statement coverages is executed. Sorry, not statement, that is a path. That path is after the execution of your statement or branch, it will execute. So your formula is total path exercised is that is divided by total number of paths in a program, and that into 100. Then you have a condition coverage. Now condition coverage is same just like your branch. If you have a branch, if you have multi-decision statements, switch and all. So for path testing may not be sufficient. It is necessary to have test cases that exercise each Boolean expression and have a test cases. This produces the true as well as false path. This means that test cases and the number of test cases will rise exponentially with the number of conditions and the Boolean expression. This is I'm talking about the condition coverage. So the condition coverage is given by the total decision. Now here I have taken the entire path. Now the decision, whatever the decision is being exercised and the total number of decision made in a program, that is divided and then it's multiplied by 100. So condition coverage is much stronger criteria than path coverage, which in turn is much stronger criteria than statement coverage. Of course, the statement we choose does initialize a variable defined or any other function statement we have executed or is examined earlier. Then we use the path and then the condition. So condition is stronger because it is tested after your Boolean expression has been tested or before your path is also exercised.